So you remember in back in algebra, or any time for that matter, when we have to add or subtract fractions, what do we first do? We find the LCM of the denominator, which is the least common multiple, and that becomes a common denominator. So for example, this one here, right, this first one here, 5 over 6 plus 4 over 9. So basically, I want the LCM, right? So between the 6 and the 9, if it doesn't immediately come to you, the official way to do it is you ask yourself, okay, what is the 6 made of? Well, it's made of a 2 times a 3. What is the 9 made of? Well, it's made of a 3 times 3, which I write as 3 squared. Okay? Now, for my LCM, I need to take representatives, right, of each type. So I need to take a 2. Between the 3's, if I have 3 to the 1 and 3 to the 2, I take the one with the higher exponent, so 3 squared. So finally, it's 2 times 3 squared, which is 18. Okay? Now, if I have a polynomial, what I first have to do is factor each of them. So if I factor that first one, I get x minus 3, x plus 2, sorry, it's x minus 2, x minus 1. Here, when I factor this one out, I get 2 times x minus 1, x plus 1. Okay? So now it's time for the LCM. Well, what do I have between the reds and all the blues? I have a 2, right? So I take a 2. I have an x minus 1, so I take an x minus 1. I have an x minus 2, and I have an x plus 1. So you need to take representatives of every single type. Okay? All right, so take a look at this next one. Between the 15, the 16, and the 20, you want to figure out the LCM. So what I do is I say, okay, 15 is made up of 3 times 5, right? 16 is made up of a couple of 2's. 2 to the what? Specifically, 16. 2 to the 4. It helps if you write it in terms of the exponents. 20 is made up of 2 squared times 5. Okay? So now I need to take one of each. So I have a couple 2's. Which 2 am I going to take? 2 to the 4. And I need a 3. And I need a 5. So the LCM is 2 to the 4 times 3 times 5. Okay? Now we move on to the coefficients. All right, so look at the a's. I have an a squared and an a cubed. I'm going to take which one? A cubed. I got a couple b's. Which one am I going to take? B to the 5th. And I got a couple c's. Which c am I going to take? C to the 6th. So finally, when I multiply this out, what do I get? 15 times 16. What do I get? $240. Okay, so that's the LCM. All right, let's do another one here. I'm going to factor the first one. I'm going to factor out an x, and I think I can factor a little bit more, right? X minus 2, x plus 1. X, and the second one is x minus 2 squared. So now what about the LCM? I need an x, I need an x plus 1, and an x minus 2 squared. Okay? Pretty cool? Because I have an x minus 2 squared and an x minus 2, and between the two of them, you want the one with the higher. So you always want to over-represent, never under-represent. Okay? Think of it as like representatives that you're electing, right? You want every demographic to have representation in the final LCM. Okay? All right. Now, what about adding and subtracting? So if we go back to that original problem up here, right? 5/6 plus 4/9. We said that the common denominator would have been 18. So let's just write that here. How do we then add these? What do we do? Well, how though? I take the 18 divided by 6, right? That why 5 times 3 and not another number? Right, and the way really it's done is you basically go 18 divided by 6, that's 3. 3 times 5 is what you get for that one, right? Plus 18 divided by 9 this time, that's 2. 2 times 4. Okay? So then you go ahead and simplify. All right, so let's take a look at this one. So first I need the LCM, right? Between the 6 and the 14, what number is that going to be?
2, 3.
Right? 6 is 2 and 3. 14 is 2 and 7. So I need a 2, a 3, and a 7. So that'll be a 6 times a 7, which is a 42. Okay, what about the variables? A squared and what? And b squared, right? Okay, so now here's what I do. I need to take this denominator and basically divide it by the first one. All right? So now 42 divided by 6 gives me what? 7. And now another one way to do it is, okay, if you were to do a squared b squared over b, what would cancel and what would be left over?
A squared b.
A squared b would be left over, right? So it's 7a squared b times that numerator. So it's 7a squared b times 5a squared. Now, there is a plus in the middle. Let's do the next one. Now it's going to be this with this. Okay, so the 42 over the 14, that's a 3. And a squared, b squared, they all cancel out. So it's just 3 times 9. Finally, this is 7 times 5, 35. A to the 4, b, plus 27 over all this mess. Okay? No, those are not like terms. Okay.
Are you able to cancel out the A's though?
No, because you're adding the 27. You wouldn't be able to cancel the A's. Okay, so I factor out the 3 here in the numerator, in the denominator, and I get x minus 5. Here I factor out the 6, and I get x minus 5. So now, what's my common denominator? Well, between the 3 and the 6, what's the lowest number both of them can go into? 6. 6, and I need an x minus 5. So again, one way to look at this is between these and these, right? The main denominator, the common denominator, and the first one. If you were to cover the common terms, what would be left over? 6 over 3, you would get a 2 times x plus 10 minus, right? So now this one and this one, if you were to cover the common things, what would be left over? Nothing. So that's 1 times 3x plus 15. So this is, you distribute 2x plus 20 minus 3x minus 15 over the denominator. So this is negative x plus 5 over all this. Okay? There is no need to. Okay? All right. So let's move on to the next one. All right, what'll be the common denominator here?
X plus 1, X plus 2.
X plus 1 and x plus 2. Okay, so now, if I take that denominator and divide it by the first one, and if you cover the common terms, what's left over? 1 times x minus, here, x plus 2 and x plus 2 are the same. What's left over? X plus 1 times 4x. Okay? So now that's x minus 4x squared minus 4x all over x plus 1, x plus 2. So what is this now? Negative 3x minus 4x squared all over x plus 1, x plus 2. Questions? Yes, no? Let's factor this next denominator.
X plus 2, X plus 6.
So the common denominator is going to be,
X plus 2, X plus 6.
right, x plus 3, x plus 6. So now, this denominator divided by the first one, we have 1 left over. 1 times 4x is 4x. Plus, this denominator divided by the second one, what's the same? The x plus 6's are the same. X plus 3 is left over times 5. Okay? So now, this is 4x plus, we distribute. Of course it makes sense, it's math. So it's 9x plus 15 over x plus 3, x plus 6. So now, somebody's going to ask me, do we have to factor out a 3?
We have to factor out a 3.
There you go. See, I knew somebody was going to ask me, do I need to factor out a 3? Well, if by factoring out a 3, you get something that you're going to be able to cancel, you have to do that. But if by factoring out a 3, you're not going to go any further and cancel things, you don't have to do it. Okay? Well, you can try it out, or if you mentally, like if you factor out a 3 here, you get what? 3x plus 5, which doesn't cancel. Okay? If, however, so suppose you left it like that, you're totally good. If you did on the test, go ahead and factor out a 3, and let's say you messed up and you did it wrong. Okay? Yeah. This would be points off. Whereas if you had left it like that, it would not have been points off, right? So just be careful.
Or is it correctly the fact that
You would get 3x plus 5, not x plus 5 inside.
Oh, right.
Okay. So next one. We factor this. No. Yeah. And here we get 5x plus 2. Okay, so the common denominator is going to be
5x. 5x. X plus 3. I mean, x minus 3.
right. So now, the first denominator, the denominator divided by the first one, this and this are the same. What's going to be left over? 5. So we do 5 times x minus 1 minus, now with the second one, 5x plus 2. So this divided by this, what's the same? X minus 3, x plus 2 is the same. No, because the x plus 2 went away. So look, what's left over here? 5. You then multiply the 5 with this denominator, with this numerator. Okay.
Why are x minus
No,
3x
but
plus
I'm
2?
saying the way you wrote it.
Oh, here the order? The order doesn't matter.
Wait, why are x minus 3 and x plus 2 the same?
Huh?
How is x minus 3 and x plus 2 the same?
They're not the same. Remember that
You just said they were the same, so you were able to
No.
read it.
these two are the same as these two. So they cancel. Okay?
Yeah.
Alright, so for the next one, what's gonna go away and what'll stay? The x plus 2 will go away. So look, 5 and x plus 2 are the same as 5 and x plus 2. What's left over? X minus 3 times 4.
What part of this did we actually need our calculator for?
None. Okay, so this is 5x minus 5 minus 4x plus 12 all over 5, x minus 3, x plus 2. So this is positive x plus 7 over all of this. Okay, so any questions? All right, so the next one, you're on your own. You're going to factor the first one, you're going to factor the second one, and do all that good stuff. I'm going to stop this recording for like 2-3 minutes and come back. Okay, so how do we factor this first one? How do we factor the first one?
4x plus 1x plus 5. Very method.
And this one is 3 times
4x plus 1.
4x plus 1. So the common denominator is 3.
4x plus 1.
Okay, so in the first case, what's left over between the two? Just the 3 times x minus 8 plus, so look at here, 3 and 4x plus 1 are the same as in, are common in the two denominators. So I have 6 times x plus 5. Okay, when we distribute, 3x minus 24 plus 6x plus 30 all over this denominator. So common mistake students make is they just start working on the numerator step after step after step after step, and then in their final answer they forget to put down the denominator again. Carry it along all the time so you don't make that mistake. So what do I have here then? 9x plus 6 over all of this. And I'm just going to switch the order of the terms on the bottom just so you see it makes absolutely zero difference. Okay? Oh my. Yeah, okay, so yeah, it makes no difference if you switch them. It does make a difference if you then write them incorrectly. Okay? So there we go. Now, in factoring out a 3, is anything going to cancel?
Oh, no, the 3 can't. Yeah,
The 3 will cancel, right? So you have to go that extra step. So look, so this is 3 times 3x plus 2 over 3 times this. Right, gentlemen? So then you have to cancel that. If you did not take out the 3, and if you did not cancel with the bottom 3, you will not get full credit, right? So the answer is 3x plus 2 over x plus 5, 4x plus 1. Whoa.
Whoa.
Okay? Any questions? All right, this homework is due next time.
We start now.